Hello, can you hear me? Hello, can you hear me?
Yes.
How are you all doing? Yes, all right, let me take down your names and we begin. One, two, three, four, five, six. Four. All right, let's start. Um, Last Friday I introduced you to regression equation. Now, let me begin by showing you what we have today. This week, this week. So here you are. All right. See your class here. Okay, let's see. All right. Please, you can see my announcement we have today and on Wednesday we have a remote class. So today and Wednesday, we're gonna have another remote class on Wednesday. So here's what we have this week. The reading material we're covering chapters 14 and 15. And then for the assignment, you have homework 10 and now complete your semester project this week. So homework 10 and the semester project are due on the December 10th. December 10th. So that's what you have this week. Now, by start today, I will I'll start on Sunday. I'm still getting your final exam ready. So I'll look at the school calendar and see when to put the final exam. Now we can begin. I think some people joined them, but I couldn't see them. Okay, they dropped. Okay. Now we can start. We are still on regression and correlation. Like I mentioned before, last week I introduced you to that, but we did an example. Today we continue with it. See if we can finish the simple regression. Okay. Now, the one we did last week is this question. And this one does not require us to test for the significance of the correlation coefficient. So the one we're doing today, we'll be doing that. We'll be testing for the significance of the correlation coefficient. So there are two methods we can do this. The first method is to use the traditional method of critical value. The second method, we'll be using the p-value to do that. So we'll be using the second method today. Let us be using the second method. Let's so that we'll be on the same page, where we test for the significance of the correlation coefficient using the p-value method. Otherwise, you can use this method, the traditional method, whereby the test statistic is this right here, and then we use the critical value. But here, the p-value, we use the p-value method, and like I explained last week, if you want to do this manual with a calculator, it will require a lot of calculations. Get all this. Then get the correlation coefficient using this formula here or this formula. That will require a lot of work. So we stick with Excel. Excel makes it easier for us. So we'll be doing another example And then this time around, we'll be testing for the significance of the correlation coefficients, which means that we're going to calculate correlation. Now, the example we did here last week using Excel, we used only the regression output, where it gave us a table, an ANOVA table, and then the values. But that one, it will give you the values. With that, you can get the regression equation and other values. You also get the correlation coefficient, but it won't tell you if it is negative or not. You can only know that by looking at the scatter plot. So to avoid that, you can just use the same method to get the regression output, which will give you even the correlation as well. But you can get the exact value of the correlation coefficient using what we call the Correl function. This one will give you the value, and if it is negative, it will tell you that it is negative. If it is not, it will tell you that it's not negative. Let's apply it here to this one. So in this question, as you can see, it says this table shows the mileage and prices in thousands of 8 cars in a car mart. See, everything here is in thousands. For example, this mileage 21.8 means 21,800. 34 means 34,000. On the price side, 16 means 16,000. 11.5 means 11,500. So we're trying to figure out the effect of the mileage on the car, on the price of the cars. So in this case, mileage is the independent variable, because mileage is the independent variable. Yes, because we can decide how much it will be. We can decide that we want to drive our car less so that it will not add so much miles on it. But the price we expect the car to attract based on the mileage, we have no control over that. So that becomes our dependent variable, or the Y variable. So now the question says, construct a scatter plot for the data. Calculate the correlation coefficient R. Compute the value of R squared and explain your result. Find the regression equation. What will be the predicted price for a car with 45,000 miles on it? Is there a relationship between mileage and car price? Use alpha 0.05. So this is where you test the significance of the correlation coefficient. When they ask you, is there a relationship between mileage and the car price? So let us begin this. Of course, the first thing we do is to put our data set in Excel. And the first thing we do, to put it in Excel. So we can you can do that here. You copy this and then paste it in Excel. Yeah. So this is a mileage and this is a car. So I'm going to remove this X and Y. You know what they are already. You know that the price is our Y variable. And that mileage is our X variable. So I will now, let me make it bigger. So now with this, we can get our regression output. And from there, we can answer, the rest of the question. Okay. So we have, let me go back to where we were. So I copied it and I pasted it here. So now we can go back to our workbook. It says, construct a scatter plot, calculate the correlation coefficient R, compute the R, which is the coefficient of determination R squared, and explain the results. Find the regression equation. What will be the predicted price for a car with a 45,000 miles? And is there a relationship between mileage and the car price? use alpha point. So once we get our regression output, we'll be able to answer these questions here. And then we can use the correct function to get our correlation coefficient to confirm whether it's negative or positive. So let's do this. Let's get the regression output. Like I explained last time, the first thing you do is to click on, after you put the data set in, next is to click on the data and click on data analysis. Then click on the regression. See regression right here, click on it. Click OK. Now for the Y range, remember this is a Y, price is a Y. So to enter that data, click on this, including the label price. Then for the X range, you do the same on the mileage. Then because we click on their names, so we're gonna check the label. And because it says alpha 0.05, so you gotta click on the confidence level. It's 0.0, so 0.95% is the chance of being wrong is the alpha is 0.05 for 95%. Then output range, click on here, and then I want the output to be, let me see, output to be placed under here. So I'm gonna click there. And then what else I need? I need the residual plot and the line of fit plot, and I also want the residual plot. These two things, then I can click OK. It will give me the results. See, it gave me the two plots, mileage, the residual. But the one the question asks us is this one, line of fit. I can see from the plot that the mileage and price, it is trending down. To me, that indicates a negative correlation. Now, as you can see here, it didn't tell us whether it's negative or positive. See? Now, with these things, all this output, we can now answer our question in that other workbook. The first question was to construct a scatter plot. So part A, say to construct a scatter plot. So you can write the scatter plot is presented below. So I will now pick up the scatter plot from here. So where is it? Right here. And then copy it, Control C, copy it, and then go and paste it in our work. Okay. Yeah, excuse me. Yeah. Mark this name. Yeah. So go there and paste it on the workbook. There's a workbook right here. Control V to paste it. And see the scatter plot right here. And like I explained, you can see the mileage, the price in the blue, and mileage and orange color. You can see that it's trending down. The cutter, so it shows that negative linear relationship between X and Y. So according to the scatter plot, here is a negative linear relationship between the price of the car Y and the mileage. X. This means that as the price, as the mileage increase, the price decrease. And as mileage decreases, the price increases, and vice versa. Any question on this? Any question? Okay, good. Excellent. Next one says calculate the correlation coefficient R. Calculate the correlation coefficient R. Now, you can get R at B. Yes. Now, you can get R from here on the output. The output we have, we see the output right here. The output tells us that the R is 0.75. I'm going to round everything here to 3 decimal places to make it easy for us. Make sure I say this. The one in homework might even ask you to have it in 2 decimal places. You just highlight it, go to, you can just right click and then choose format cells. Let's see. Yeah, right here, format cells. And then choose number. See, 2 decimal places, let me make it 3. Okay. Now, this told us that R is 0.75, 0.758, as you can see from the screen, but it doesn't tell us whether it's negative or positive. That's why it's better for you to calculate it using the Correll function. So let us use the Correll function to calculate the correlation coefficient. The correlation coefficient is, now, yeah, this is the Correll function, how it goes. I'm going to show you. So right here, equals the Correll array 1, comma, and array 2. So the array 1 is the range of the data in the first variable, which is this one here. And this is the range on the second variable, which is this one here. So now let us use it to find our correlation coefficient. I'm going to take it back to the Excel. So you can just come here and write equal Correll. If it pops up, double click on it. And for the first variable, you click, this is it, comma, the second variable, here, then close the parenthesis and press the enter key. See, it gave me the value right away. And it tells me if that is negative. So you can see why this method is more reliable. I'm gonna format this and make it 3 decimal places. Choose number. 3 decimal places. Okay. So it will give you the answer. So for example, if you're taking this exam, you're taking this online. I mean, if you're doing a homework or it's an exam and they have this, it gives you the option of exporting that data to Excel. You can just use the Correll function to find the correlation coefficients. So you get it as negative 0.758, which is what you have here, but it's positive. So that's why this one will tell you whether it's negative, the Correll function. So we got it as negative, okay? So which means that we go down to here. So our R equals negative 0.758. See, which confirm what we have in the chart. Chart stated that it is there's a negative linear relationship between price and the predicted price and the price and the predicted mileage and the predicted price. Sorry. So when the mileage is high, see the price is low. When the mileage is low, the prices are high. So now that's the same where we interpret our R. So that means that there is interpretation of this. I mean that there is a negative relationship between the price and the price and the correlation coefficient. Let me say the price and the mileage. So when the mileage is high, the price is low. When the mileage is low, the price is high. Any question on this one? Any question? Okay. All right. Next one is question number 3. Part C. Part C says, compute the value of R squared and explain our result. Well, R squared is given already there. Like I said, the regression output gives you everything. Yeah. R squared. The R squared is, so I'm gonna make this R squared. So it is R squared equals, now we go to our output again. Our regression output. You can see the R squared right here. So R squared is 0.574. Write it down. R squared equals 0.574. Otherwise, you can get it with a calculator. 574, and you can copy it. Okay, and place it here. 0.574. Okay. Otherwise, like I said, you can get it from your calculator. Using what they call the key for the R square. You can get this calculator. Let's see, have it here. So we have negative. First of all, we have negative 0.758. So you can get the R square, square it. To give it the R square 0.7574. Or you can just pick it from the Excel output and put it in like we did. So, which is the same as saying that interpretation, prediction. You see that about 57.4% decrease. Or you can use change. Okay. Okay. I use decrease because the correlation coefficient say that it's negative. You can just say change. And the price of car is caused by the increase in mileage. Again, you can just use change if you don't know whether if you don't know the direction use. You can just say that 57.4% change in the price of the car is caused by this change in mileage. Yeah. The equation. Yeah. No question. Good. 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 The next is the part D. Part D say find the regression equation. Find the regression equation. So the regression equation is, as you know, is y Let's see. The regression equation is y equals mx. Ax is of course you know that from the general uh, um, regression equation that one part is the intercept, the other part has the x value. So you have BO, okay, plus B1 x, okay, and I have it here actually for when we did it when I was introduced the regression. I can say BO plus B1 x. So we can just make some adjustments to our what you have here, B1, and this one with the regular, you know, X. This is our regression equation right there. Make it bold. So that means we're going to find our BO. BO equal, then find our B1 equal. Put them in, and then we can write the equation again. So from here, we can find that our BO is this for here. BO, I'm gonna make this this is the when we have this, see where they are located under the coefficients. So I'm gonna make this 2 decimal places or 2. Okay, depending on what the equation wants. Make it 2 decimal places, good. Okay. Now I click OK. So have our regression equation. So this is our BO. Our BO is this, and our B1, sorry, yeah, our B1 is this one. Yeah. So one of them is mileage. So with that, let me write these numbers down. BO equals 17.10, and B1 equals negative 0.09. So we can now use it to write our regression equation. So that our BO is, we get at 17.1, and B1 is negative 0.09. So that our Y becomes equal, it says BO plus B1x. BO is the intercept. Remember, the B1 is the slope. BO is the intercept, B1 is the slope. So of course, you know that Y is the price and S is the mileage. So we have 17.1, okay, minus, now of course, for here, for B1, we have negative 0.09 x. See, this is our regression equation right there. See? Now, what does this mean? How do we interpret this? Okay. How do we interpret this? Now, remember, slope is the rate of change. And if you recall, all these numbers here are in thousands. Okay. So this will have negative slope here. It shows that negative slope means a decrease. So we can say that the price of a car, if I want to use the 1,000, so this thing 0.09 times 1,000. Usually we check mileage per thousands. I mean, for cars, you know, how many thousand it is. This is 0.09, right? But in thousand, you're gonna be let me see, 0.09. You got 0.09 times 1,000. It's 90, right? So with this, that means that we can say that the mileage, according to this equation, okay. Yes, Kajo, Ms. Kujo, you have a question?
Why were we timing it by 1,000 again? I forgot.
Okay, yeah, because first reason is that we want to interpret it. Second reason is that everything at the original table is in thousand. Remember, these are in thousands. So 21.8 means 21,800. So when you want to interpret it, you change it to thousand so you can write the interpretation. We're not changing the actual number to thousand, but for the interpretation, to make the person you are trying to explain it, understand what it means, you convert it to thousand to have a good interpretation. But you're not going to change the answer here to thousand. See? So everything is like here, we have 17.1, that means 17,100. So everything is in thousand. But to make the calculation simple, I just removed the number. But it said here, prices in thousands. Mileage is also in thousands. So does that answer your question?
Yes, thank you.
You're welcome. So now, so that means 90, right? So we're not going to change this number in thousand answer because the table gave us the answer, remove the 3 zeros. But when we interpret it, we have to remind ourselves that everything is here is in thousands. So you say that according to this equation, because it's a decrease, the car price decreases, okay? Now, that's what I remember. Decrease. This is now. Okay, let me just write it and then I'll explain more. Decreases over time at the rate of $90 per 1,000 increase in mileage. Okay. Now, Ms. Kujo, suppose that you don't want to change it to actual increase. Then you can write this. Let me show you how it sound. You can write this. That the car price, this is basically 9 cents. That the car price increases over time, decreases over time at the rate of 9 cents for each increase in mileage. See? Now, both of them are correct. But remember that mileage we say in thousand. That's why I move it to thousand. Right, so you can say 9 cents per each the car price decreases over time in 9 cents at the rate of 9 cents for each increase in mileage. See? So that both ways are correct. Somebody else came in. I just forgot the name. Okay, I think I see it. All right. Any other question? Good. Good. So now let's see the next question. Since the next thing that they want us to do, since there's no question yet. Somebody else come in? No? Okay. Let's see the next thing they want us to do here. Okay, yeah, we're good. You guys can see the screen, right? All right. Now, the next thing they want us to do here is, which is, okay, we did that already. Find the equation. Let's see, what would be the predicted price for $45,000, 45,000 miles? See, here again, This 45,000 miles will be written as 45. But remember, everything here is in thousand, but I remove the 3 zeros to make it easy to calculate. So that means that this 45,000 miles will be written as 45. But when you write the interpretation, you write it as complete thousand. So you say, what would the predicted price be for a car with 45,000 miles? I'm going to write this thing. X equals to 45. Okay. So E, that's part E. If X is 45,000, that's part E. Okay. E, say X is 45,000. 45,000. Okay. 45,000. So we're gonna write it as X because remember we remove all the zeros. So X equals 45. So to answer that question, we just use the regression equation and plug it in there. Y equals 17.10 minus 0.09x. Okay. All right. X. So when X is 45, which is 45,000, I'm going to have the same thing we have here. But now we replace the X with 45. So we're going to put 45 here for X. Okay. And that will give us the value. So I'm going to write this down here. Y equals 17.10 minus 0.09, 45. So I'm going to take you to the calculator so we can figure this out. So we have clearing this. So it's 17.1 minus 0.09. Oh, excuse me. 0.09 times 45. It was 13.05. 13.05. Okay. 13.05. 13.05. Which is, of course, remember these are in thousands. That means $13,050. So that means that a car whose mileage is 45,000 will cost 13,050. See? So that answers that question. Okay. So let's write the interpretation here. Interpretation. So it says that here, a car, the price of a car, the price of the retail price of a car with a mileage of 45,000 is 13,050 cents. Any question on that? Yeah. Okay, excellent. No question. Good. Now, the last segment of that question is here. Is it, is there a relationship between the mileage and car price? Use alpha 0.05. Now we have that here. First of all, you state the hypothesis. That's part E. I think F, right? Part F. You state the hypothesis. This is how we state it. HO, rho is not equal to 0. Sorry, rho is equal to 0. That means the car price and mileage are not linearly related. And H1 is rho not equal to 0. That means they are linearly related. And they say that to use alpha 0.05. So now this is our alpha. Let's find our p-value. P-value you have it there already. If you go to our Excel output, you can see that we have a p-value right here. See, make it see the p-value right here. That's the section for p-value. I'm gonna use this. See, so we're looking at the mileage. See right here, it is a p-value. You can see it is it's just a long number. So let me make it. Let me make them 2 decimal places. Right click on it, make it I'll make it 4 decimal places. Doesn't matter. It's usually 4 decimal places anyway. I'll make it 4. Oh, excuse me. Okay, this is a p-value right there. 0.0294 p-value equals 0.0294. So we go there and put it in. 0.0294. Now we compare them, the two. You can see that the p-value is less than alpha. P-value less than alpha. So in that case, we reject decision. So we have reject HO because the p-value of 0.0294 is less than a alpha of 0.05, alpha of 0.05. See? So that the decision is this. Decision. Mileage. Car price. Remember the question they asked us. So we rejected this. Sorry, we did not. We rejected we rejected the null hypothesis, which is this one. That means we're accepting this. Okay. So that the car price and mileage are linearly related. Car price and mileage, excuse me, are linearly related. So if you look at the question, it says, is there a relationship between mileage and car price? Yes, there is a relationship between them since they are linearly related. So from the beginning part, the scatter plot showed us that there is a negative relationship between the two of them. And our R say the same thing. R square, okay, we use decrease. So here, an increase here. In telling us the kind of relationship they have, okay. Yeah, okay. 1 minute. Check this. Okay. Now, then this our test also confirmed it. So basically, the class is almost over. What we need to do now is, when you get a chance, you practice this one. But on Wednesday, we'll do multiple regression. That's why we'll see how we be there. That'll be our last lecture. That's Wednesday. We do the multiple. That will require us to use this kind of regression equation. Now, next week, I'll put the finance. So next week, I'll look at the school calendar and I'll know so I can know the date to put the final exam. But the final exam, if you have please have a question, ask me. I don't respond to chat when I'm in doing a remote class. Now, the final exam, I don't think there's anything to panic because they're basically what you took 2 tests already. So you just what percentage of your this course is the final exam? Let's see. I'm gonna take you to you can see the percentage of the final exam. What is what? I'm taking you to the assignment. Miss Kujo, you have a
Um,
question?
yeah, I had a question before you took us to assignments. In
Okay.
the last problem that we did, so to
Mm-hmm.
clarify, to find HO or H1,
Mm-hmm.
if the number is less than A, we always reject, and then when
Yeah,
the number is
yeah,
over
yeah. If you're
A,
using the p-value method, if you're using the
mm-hmm,
p-value method, p-value method,
mm-hmm.
if it's less than, you reject. If it's more than, you don't. But if you're using the critical value method, it's the opposite. If your answer is greater than, you know, so
Okay.
yeah, you reject, and if it's smaller than, you don't reject. So for
So for
go ahead.
critical value it's the opposite, but for p value it's like
Mm-hmm.
okay, got you. Thank you.
Mm. And the funny thing is that if you use both of them, like let's say like this one, we rejected null hypothesis. If you use the critical value, you're still gonna reject. It will give you the same outcome, even though they have the two different criteria for making decision. Yeah.
And so when we do this, we also don't have to do the we don't have to because you said the p value and you showed us two of them and we did the one for the first hypothesis. So we don't have to do the work for the second hypothesis once we've already rejected the first one.
Yeah. Once you reject the first one, that means you automatically you are almost as saying that the other hypothesis is good. So,
Okay, thank you.
yeah, you're welcome. So assuming that we did not reject no hypothesis. That means this one that I highlighted is not good. Is like there's no sufficient evidence to support the claim. Yeah. Any other question? Ms. Kujo, you good?
Yes, I'm good, thank you.
You're welcome. So now, see, the final exam is only see, yeah, it's only 20% of your grade. So now do the homework, complete the assignments. That's the main thing. And I'll see you on Wednesday. Don't forget, we're having another remote class on Wednesday.
Professor,
Yes, ma'am.
Are you opening
Professor,
up all assignments?
I'm not opening all assignments. I open assignments individually based on your attendance score.
Okay.
So if you want that, if you want, let's say that and I'm not opening every assignment. Some of them, like if you want, let's say you want
hmm,
homework open for you,
for you.
send me an email.
Mm-hmm.
After this, I'm gonna look at my email again after this class, and then I'll
Okay.
open it for you, the homework. Not classwork, homework. Classwork, we are past that now. We are getting past that, except for special occasion. And again, it depends on your attendance score. Okay?
Okay.
Professor,
Yes, ma'am.
this is Anaya Curtis. I had to join on my
Oh,
phone
Miss
because it
Curtis.
wouldn't
Okay,
let me join.
go ahead. Go ahead. I'm
Yes.
listening. Hmm.
No, I was just saying it. I was just wanting to let you know because I don't know if it told you my name or not.
For the yeah. Okay,
For like my attendance and stuff.
okay. I checked it now.
Okay, thank you.
You're welcome. Any other question, guys? If there's none, then I'll see you on Wednesday. Okay. Any more questions?
I just have a personal question.
You want to send it on the email then, or you want to say it?
No, I can ask it now. I was
Okay.
just hoping if you could open up homework 9 for me.
What's the name?
Michaela Cujo.
Joe. Okay. I see you in class. Some just they say trust but verify, right, Mr. Kujo?
Mm-hmm.
Say trust but verify. So I'm gonna verify. And okay, you have a good attendance, 92. Oh, wow. Which one is that? It says
Homework
what
number
is that?
9.
Number 9.
Yeah.
Yeah. Give me 1 minute. Let me open it for you. Mr. Kujo. I gotta go inside there. MATLAB. Yeah. Yeah, I gotta individual students. your individual students. So my name is not in this list, so I'm gonna add it to the list. Could you add to the list? All right. Okay. Good. So homework 9, you said?
Yes.
Homework 9. All right. So Ms. Kujo, I'm giving you to Friday to get it done, okay?
Thank you.
You're welcome. Friday should be, what's today's date? 4. So Friday should be the 8th. Okay? Get it done by that date and you should be good.
I will. Thank
It's
you.
now open there for you. All right, guys.
Thank you so much.
You're welcome. I see you guys on Wednesday then. Have a nice day. This one I want me to put close.
Bye, Professor. Don't